Our player is powered up, armed, and ready to go. Let's create some hazards to challenge our player. We will be creating an asteroid prefab to throw at our player, and we will use an architecture similar to the one we used to make the bolt prefab. We will have a parent game object for the logic, and the artwork will be a child. To start, let's create a new game object, and rename it Asteroid. Reset the asteroid's transform to Origin, and move it up along the z-axis to about 8. By moving the asteroid parent a little further up the game area, it will both separate the asteroid from the player while we build it and allow us to easily test it when we are finished. Next, let's get some artwork for our asteroid. If we open the Models folder in Assets, we have 3 asteroid models to choose from. We are going to use the first one. Select the asteroid model and drag it onto the asteroid parent game object. When we drop it, the asteroid model will be a child of the asteroid game object. I'm going to reset the model's transform. By resetting the entire transform, the model will be centered on the parent game object, with no relative rotation and a scale of 1 relative to the parent game object. For our game, it's important that the transform's position be at local origin. The game is designed to work with the asteroid model at a local scale of 1, but we may find it interesting to experiment with local scale after we are done with this project, to see how it changes the game and gameplay. With our artwork in place, let's set up the components and logic. Select the parent asteroid game object and use the Add Component button to add a physics rigid body. As our game is playing along the XZ plane, deselect Use Gravity so the asteroid does not fall into the void. Now, let's use the Add Component again to add a Physics Capsule Collider. Again, we have what looks like a green wire sphere around our asteroid. We need to change the radius and the height of the capsule collider to more accurately match our model. Now, we could try to set these using the properties on the component, but this is a less than ideal way of doing things. We can, however, change the shape of the capsule collider directly in the scene view. The trick here is to hold down the Shift key. When we hold down the Shift key, drag handles appear on the collider. With these, we can simply drag the collider's shape until we are satisfied. Now that we have our basic physics component set up, let's save the scene and enter play mode. Wow, that's one boring asteroid. Exit play mode. Let's give it some life and make it tumble. With the asteroid game object selected, use the Add Component button to create a new script. Rename the script Random Rotator, and accept the changes to add this script to Asteroid. Select Assets, and file the new script into the Scripts folder. Open the Scripts folder and select Random Rotator, and open this script for editing. The first thing we want to do is create a public float called tumble to hold our maximum tumble value, which we will be able to set in the editor. Now, in Start, we want to set our rigid body's angular velocity. What is angular velocity? Angular velocity is how fast a rigid body object is rotating. And we want to set our angular velocity to some random value. Now, Unity has a random class, and it's very convenient for giving us all sorts of random values. The most basic is literally random value. This will return a random float value between 0 and 1, and then we can do anything we want to with this random number. But there are several more interesting items in the random class that can give us more complex and more useful values if we look at the class in detail. For our asteroid, let's look at random inside unit sphere. This may sound intimidating, and it may also sound like it has nothing to do with tumbling an asteroid, but in actuality, it is everything that we need. Inside unit sphere gives us a random vector3 value that we can apply to our rigid body's angular velocity, and each of the 3 X, Y, and Z values will be randomized individually. Copy random inside unit sphere and paste it into our code and multiply it by tumble. This simple script takes our tumble value from the editor, and at start, we set the new asteroid's rigidbody.angularVelocity to a random vector3 value from random inside unit sphere, and then we multiply this by tumble. Save this script and return to Unity. Select asteroid, and let's set the tumble value to 5. Save the scene and enter play mode to test. And our asteroid now has a random tumble. Let's enter and exit play mode a few more times. We can see that every time the script calls start, we get a different random angular velocity. If, however, we leave it for a short period of time, the asteroid slows to a stop. This is due to a default value on the rigid body component. The rigid body has two parameters to simulate resistance, like air friction, and these are drag and angular drag. Angular drag, by default, has a small but working value. Exit play mode. Let's drop this value to 0. Enter play mode. Now, our asteroid has no angular drag being applied to its angular velocity, so it will keep tumbling until it's destroyed by the player or by the boundary. Exit play mode. Speaking of which, what happens if our player tries to shoot the asteroid? Enter play mode. Nothing. Our asteroid has a collider on it, and so do our laser bolts. Why don't we see any interaction? That's because they are both trigger colliders, and triggers don't have physical collisions, and we have written nothing that can capture the trigger event. We will need to write more trigger-related code for our two colliders to have any effect. Exit play mode. With asteroid selected, use the Add Component button to create a new script. Rename this script Destroy by Contact, and accept the changes to add this new script to asteroid. File the script, and open it for editing. After removing the sample code, let's write trigger again and search the documentation. In this case, we want to destroy the asteroid when the bolt first touches it, so let's select On Trigger Enter. This code is very much like the code we used for our boundary, except this code is called when a collider first touches the trigger collider, rather than when the collider leaves the trigger volume. This sample code is also convenient, as it does almost everything we need. When another collider enters the trigger, we are given a reference to that other collider as collider other. The code then destroys the other collider's game object. Copy this code and paste it into our script. This code, as it stands, will destroy the laser bolt when it hits the asteroid. Next, we need to destroy the asteroid itself with Destroy Game Object. Destroy Game Object will destroy the game object this script is attached to, which in this case is the asteroid, and all of its children and all their attached components. One quick note about destroy. Destroy does not immediately destroy the object listed in the parentheses. It marks the object to be destroyed, and all of the marked objects are destroyed at the end of the frame. So we can put these destroy lines in any order. It seems wrong if we destroy this game object before we call destroy on the other one. But code-wise, it doesn't matter what order we mark our objects to be destroyed, as long as they are marked in the same frame. Save this script and return to Unity. Again, this script has no properties for us to set in the editor. It will just work as long as it's attached to an active game object. Let's save our scene and enter play mode. Where's our asteroid? Let's exit play mode. There it is. OK, enter play mode. And it's gone. We can see our asteroid in edit mode, but it vanishes in play mode. No, we aren't standing at a flux point in the probability field, we have a bug. Let's do some simple debugging. Let's exit play mode. Return to our destroy by contact script. If something is calling our new trigger code and destroying our asteroid, we need to find out what that something is. In onTriggerEnter, let's write debug.log other.name. This will send the name of the game object that other is attached to as a line in our console log. Save this script and return to Unity. Enter play mode, and now we see who the culprit is. It's boundary. We see the most recent error or message in the footer. We can also check the console for more detailed information. If we look into the hierarchy, we can see that boundary is also missing from our scene. It has been destroyed. Exit play mode and switch to the scene view. Now, if we focus our scene view camera on the boundary, we can look at the relationship between the asteroid and boundary. Asteroid is right there in the middle of the boundary. On the very first frame, asteroid detects its inside boundary, and boundary triggers our onTriggerEnter code on asteroid, and the code destroys both game objects in the very first frame. We need to test our onTriggerEnter code and ignore collisions with boundary. One way of identifying an object is with a tag. Let's tag our boundary. Select boundary, and in the header of the game object is its tag. We can see it is untagged. Click on the tag drop-down and select Add Tag. This brings up tags and layers in the inspector. Our custom tag list is empty, so let's add a new tag, boundary. Now, if we look back at our boundary game object, we can see it is still untagged. This is an important note. We used Add Tag on the tag drop-down to create a new tag, but we still must assign that new tag. So with boundary selected, click on the tag drop-down and select boundary. We now have successfully tagged this game object as boundary. Return to our destroy by contact script. Let's remove our debug line and replace it with if the other tag is the same as boundary, then return. Return ends the execution of a function and hands the control back to the function that called it, which in some cases may be Unity itself. Optionally, a value can be passed back as well with return. In our case, return simply ends this function at that point and returns the control back to Unity's game loop, which means we will never reach or execute the destroy code if the other's tag is boundary. Save the script and return to Unity. Enter play mode, and there's our asteroid. Fire our weapons, and the asteroid and the laser bolt are destroyed. When the asteroid entered the boundary on the first frame, the trigger message was cut short and the destruction code was ignored. Now we have a tumbling asteroid and destruction code. In the next assignment, we will add explosions, move the asteroid, and save it as a prefab for our game controller to use.